Hello students, today in this video we are going to study about the exponential functions integration. Now our success criteria is to evaluate the indefinite integrals applying the exponential rules of integration. Also, if we will get the time, we will see how to analyze, solve problems involving the real life situations applying the exponential rules of integration. So we all know that if we are asked to take the derivative of the function e to the power x, so its derivative is same like e to the power x. Now if we want to go back to the original function, then of course we have to take the antiderivative of the differential equation. So if we are asked to take the antiderivative of e to the power x, then its antiderivative is also e to the power x. So the derivative and antiderivative of the natural exponential function is same. Similarly, if we are asked to take the antiderivative e to the power u, where u can be any function other than 1x to the power 1, so it is very necessary that that the derivative of the u should be written inside the integral sign. If it is so, then yes, we can apply the exponential rule and our answer will be e to the power u plus c, where c is the constant of integration. So based on this formula, we are going to solve many questions. So here, first of all, the antiderivative of different functions. It is not considered as one function. The reason is that the derivatives are not written outside. There is no power. So, and they are, all the functions are separated with a plus or a minus sign. So, antiderivative of e to the power x is e to the power x. Remember that e to the power negative x antiderivative of e to the power negative x, how can be taken? So derivative of u is in the power, derivative of u is -1. We don't have -1 inside the integral sign, so we just put a negative sign inside and outside to balance the equation. Now this negative sign is as it is, and derivative of e to the power u, if its derivative is written inside, then it is e to the power negative x. So here the antiderivative of e to the power negative x is negative e to the power negative x. Now e is a constant number and we know that antiderivative of c dx is cx. So here we don't have the c, we have the e. So antiderivative of e is ex and then put a constant of integration. So here, have a look here. The antiderivative of the u, which is written in the power, is 2x, which is already written. So e to the power u prime is written. Answer is e to the power u. So you have to write only e to the power 2x plus 1. Now again, look at the power. The power is 5x minus 1. The derivative of 5x minus 7 is 5. So it is written here. So it means we have the general form e to the power u prime. So just your answer will be only e to the power 5x minus 7 plus c. Let's try the last one. So e to the power x square minus 7. Focus on the power. The derivative of the power is 2x. So 2x is written beside e to the power x square minus 7. So the whole form of e to the power u prime is there. So answer is only e to the power x square minus 7. So here, let's see the question. E to the power 7x plus 1. Focus on the power 7x plus 1. The derivative of 7x plus 1 is 7, which is not in the question. So what do? You multiply and divide the 7 to this function. So write the 7 inside and 1 over 7 outside the function. Now 1 over 7 you will write as it is because it is out of the integral sign, and here you have the u prime and you have e to the power u. So the answer is only 1 over 7 e to the power 7x plus 1. Now let's check one more thing. Here focus on the power. So it is x square minus 9. What is the derivative of this function? It is 2x. So you can see here the x is written, only the missing number is 2. So we will multiply and divide with the 2 in order to get the perfect derivative inside the integral sign. Now we have 2x in the shape of u prime and we have e to the power u. So the half we will write as it is, which is out of the integral sign, and the answer is e to the power u, which means e to the power x square minus 9. Let's practice one more. So focus on the power, that is x cube minus 7. The derivative of x cube minus 7 is 3x square, and you can see closely that 3 is missing. X square is present whereas 3 is missing. So multiply and divide the 3. Write 1 over 3 outside the integral sign and 3 inside. Now you can see u prime is there, e to the power u is there. So write 1 over 3 first of all and e to the power u, that is 1 over 3 e to the power x cube minus 7 plus c. Let's see some more complicated questions. Again, focus on the power of the e. So the exponent is written as x square minus 2x minus 1. Check what is the derivative. The derivative is 2x minus 2. Now if we take the common factor 2, so we will be left with x minus 1. And now you can check that here x minus 1 is present, there is a missing number, that is 2. So we write the 2 inside and 1 over 2 outside. Why we do so? So now 2 to 2 bracket x minus 1 is considered as the u prime and e to the power function is e to the power u. So now the answer is only e to the power u. So you will write half and then e to the power x square minus 2x plus 1. Here again, focus on the power, that is 5x square minus 20x. Now take the derivative of this function. So you will get 10x minus 20. Now if we look here in the question, we have 2x minus 4 given, which means that 5 has been taken as the common factor. So 5 times 2, 10. 5 times 4, 20. So it means the missing number is 5. So we write the 5 inside and we divide the 5 outside the integral sign. Now we write 1 over 5 as it is. This is our u prime and this function is e to the power u. And we know that if e to the power u and u prime is written, answer is only e to the power u. So our answer is 1 over 5, that is written outside the integral sign, and e to the power function as it is. Okay. Now let's see one more question. Again, focus on the function which is written as an exponent, that is x cube minus 6x square plus 18x minus 15. Take the derivative. So you will get 3x square minus 6 times 2, 12x plus 18. Derivative of 15 is 0. Now closely check which number is missing. So if I look at the first term, I can see very closely that 3 is missing. So let's try to take the 3 common and check if this matches to our given function or not. So take 3 common, we will get x squared minus 12 divided by 3, we will get 4x plus 18 divided by 3, we will get 6. So it is written here. So we can say that 3 is missing number. So we multiply the 3 inside and we write outside 1 over 3. So now here we have been given u and u prime and e to the power u is given. So the answer is e to the power u. So we will write 1 over 3 and only the e to the power x cube minus x squared plus 18x minus 15. And don't forget to write plus c because it is indefinite integral. Let's try one more question. What have you noticed over here? Here we can see that there is a function which has a power. So whenever we have a function with power, so we will consider it as a complex function or a composite function. So we have a composite function and we have studied previously that whenever we have a composite function, it consists of the inner function and the outer function. Since there is a power, so the power is always be considered as the outer function. So our inner function, now focus on the inner function. Focus on the inner function which is e to the power x minus 18. Now check if its derivative is written out of the integral sign or not. So derivative of e power x is e power x, derivative of 18 is 0. So yes, if you see e to the power x is written. So it means we have u to the power n formula. We have to apply u to the power n formula because the derivative of u prime is given to us. So once we have the derivative, we can write the bracket thing means the inner function as it is, add 1 in the power and whatever we write as a power, we divide it or write it in the denominator. So let's check one more question. So here, what is the main function? I can see there is a power. So I know if there is a power, so I have to take the bracket function, the function which is given in the bracket as the inner function. Now I am writing on the right hand side to just show you that e to the power x plus 1 is our inner function. What is the derivative of e to the power u? It is a chain rule. So we write e to the power u as it is and then u prime. U is the power. So derivative of x plus 1 is only 1. Is it written outside the bracket? Yes, it is written outside the bracket. So once the power, the u with a power of something is written and its derivative is written inside, we attack on the outer function. That means on the power, we add 1 in the power and divide with the same number. So here e to the power x plus 1 is our inner function. Add 1 in the power, that means 13 plus 1, it is 14 over 14 plus c. Now let's check where is our composite function. There is a composite function with a power 100. So let's write here the inner function, that is e to the power 2x minus 3. Take the derivative. Now e to the power u. The derivative of e to the power u is e to the power u and u prime. Means the chain rule. So e to the power 2x, the derivative is 1 time as it is and 1 time the derivative of 2x, that is 2. Now derivative of 3 is 0, so just no need to write the 0. Now compare this e to the power 2x times 2 with the function that is given inside the integral sign. So we can see that the constant number 2 is missing. And it is our general practice, if there is something missing, we write, multiply and divide with the same number to balance the equation. Now what is here? You can see we have u prime we have u to the power n, and there is 1 over 2 outside. So the answer will be 1 over 2 because it is out of the integral sign as it is. In the power, we won't write that u prime in the answer. We only attack on the outer function. We write the inner function of the composite function, that is e to the power 2x minus 3. Add 1 in the 100, that is 101 over 101 plus c. But don't forget to write this 1 over 2 which is written outside the integral sign. And now multiply 2 times 101, you will get 202 in the denominator. So based on the same u to the power n u prime concept, solves few more example. What have you observed? That there is a function which is written in the denominator, and most important, it has a power. So if we have any function written in the denominator with some power, the first step is to bring it on the top and change the sign of the power. So we will write e to the power x minus 18 whole to the power negative 2. The numerator e to the power x stay as it is. Now, since we have a composite function, so check if the derivative of e to the power x minus 18 is written outside. Yes, the derivative of e to the power x is e to the power x, which is written beside it. So we have u to the power n and you have u prime. So what we will do, we write the u as it is, that is e to the power minus x, e to the power x minus 18. Add 1 in negative 2. So negative 2 plus 1 is negative 1 and divide by negative 1. Now if it is negative 1, you can bring it down and make it positive if you want, otherwise no need. So if I want to bring it down, so 1 over negative 1 will gives me negative 1 as it is. You write up or down makes no difference. Just bring this negative power down to make it positive. Minus 18 only and plus c. Now let's see here. In the second question, here we have a power, we have this radical sign, square root sign in the denominator. So radical sign, we know it has a power of half. So bring the power half or convert it into the exponent and bring it on the top. So when you bring the half on the top, you will get negative half. Now let's check. I am writing here with the steps. So e to the power minus x and e to the power minus x minus 1 whole to the power negative half I am writing here. Now what is the derivative of e to the power minus x minus 1? It is minus e to the power minus x. So you can see that minus is missing. So if minus is missing, we write inside and outside the integral sign. Now everything is at its place. We will just add 1 in the power using the power rule of antiderivative. So don't forget to write this minus here. Write the inner function as it is. Ignore the all derivatives and the dx. Just add 1. So negative half plus 1 gives you half. Whatever we write as a power, we have to divide that number. Divide the equation with that number. So that is how we solve and how we analyze the questions. Let's see this one. So here cubic root of e to the power 2x plus 2x is written. So once we bring it, we should know that cubic root can have a power 1 over 3. So bring it on the top, you will get the power as negative 1 over 3. So I am writing here to show you e to the power 2x plus 1, which is written already in the numerator. It is written already. And we bring it up, e to the power 2x plus 2x as it is. Bring this up, we will get negative 1 over 3 dx. Now look at the composite function's inner function, this one. And check what is the derivative of e to the power 2x. So the derivative of e to the power 2x is 2e to the power 2x, chain rule, plus derivative of 2x is 2. Now, if we look this answer, this derivative with the function given in the numerator over here, we will see that 2 is missing. So if we take the 2 common, we will get e to the power 2x plus 1. So it means 2 is missing. So according to our practice, we multiply the 2 and we write outside 1 over 2. Means we divide the 2. Now we ignore our derivative. We ignore our dx, means the command. Only we write the inner function as it is and add 1 in the power. So negative 1 over 3 plus 1, it gives you 2 over 3 divided by 2 over 3 plus c. Then you will just make the simple calculations.